Hello everyone, we are going to continue with the second part of quantum mechanics for children. This is the second part and we are going to talk about interactions. Okay, usually in quantum mechanics or in classical mechanics it is used the concept of Hamiltonian to express interactions that are associated with interactions. When we describe a Hamiltonian, quantum mechanics is an operator. We require here put the interactions that they will be involved. For example, if we have one particle and this particle is inside a field where this field modifies the trajectory of the motion of the particle, we must consider this field or a potential. Therefore, the potential which will be involved the particle, now the particle which we want to discuss is this particle. So is this particle that we want to discuss, and therefore the Hamiltonian, which it will be expressed by two parts, the kinetical energy plus the potential energy. The kinetical energy is the energy associated with the momentum which carries this particle, let's call particle P. So has a momentum, this particle carries a momentum P. Okay, let's use another word to the particle. Okay, let's call the particle B. Okay, the particle B, we requires, or this particle has a motion, and the movement or the motion of the particles associated with the mass of the particle, which has this particle B, with a mass m and has a velocity. This is the velocity, is not this v, this v is the potential. Okay, we can rewrite the potential with another letter. The letter that we can use to potential is u, v is for the velocity. Therefore, the kinetical energy associated with this particle in classical mechanics is this one, and the extra term, or the next term, which is connected with potential energy, is the u, that is this one. And let's consider just at the moment that we have in one dimension. Okay, this is the classical approach. So the Hamiltonian is just the mass of the particle and the mass of the particle and and the mass of the particle and the speed or velocity of the particle to the square plus the potential. If we have this situation which only we have, okay, we have here the planet, here Earth, and here we have this particle. We have here one potential. This is the gravitational potential. If we have the gravitational potential, the gravitational potential, we can write down mg mgh. That is the if we have here the particle and the distance between the surface to the particles h, this particle has mass m, and we have a gravitational force which has a constant g. Therefore, the potential energy associated with this particle is this one. So this interaction is the interaction due to gravity. Here, the interaction that we can take into account is just the speed, is the kinetical energy that we have. But here we only consider one particle. We don't have many particles. And now in quantum mechanics, we have another formalism to express these phenomena. Now for observables, we must associate operators. So the operators and observables that we have here in this example is the follow, the momentum, that is P, is the observables. Now what we write will be written like this. The position now will be this, but this operator will remain the same. And here we quantize the momentum. This is the operator. We introduce a new operator that is the operator nabla, and this operator for one dimension is this. So if we have p squared over 2m. So we put this to the square. Here is square 2m, and this is e. This is minus i minus h bar square